You never know how science evolved, and sometimes something happens that opens up completely new research field. And recently, one of these research fields would be field of plasmonic metamaterials, where combining very little, very small nanoparticles, very small nanostructure into larger into larger arrays, larger assemblies, one can achieve optical properties which are not possible in nature. And by doing this, you can engineer the way how light interacts with matter in completely new ways, in completely unseen previously ways. And obviously, if you have this new effect, you can improve various functionalities. For example, you can control light with light at very low light intensity, because usually in normal material, if you send one beam of light, another beam of light, they will not interact. However, if you construct your metamaterials in correct way, you can achieve this interaction of light with light, which has a great opportunity for signal processing, for optical signal processing, for data communications. So this recently was one of the significant developments in the field. So these metamaterials, they can be of very different structures, yes? So they can be kind of either small metal particles, like very small, like a few tenths of nanometers, arranged in arrays, again with period of few tenths of nanometers. It can be spherical particles, can be particle shaped as nanorods, okay, can be more complex shapes, but the range in periodic or aperiodic ray does not matter, because distance between these particles, between these components of metamaterials are so small that light can see only many of them. So it's much smaller than wavelengths of light, so light can see many of them, and this is where these new opportunities, new functionalities come from. By changing lead periodicity of these arrays, or changing lead bit size of nanoparticles, or changing materials out of which these nanoparticles made, you can achieve completely new functionality. You can control if this new properties happens in visible spectral range, or this new properties happens at telecommunication range, or terahertz, or radio frequency. So it's really field that impacted photonics and electromagnetics in kind of very broad spectral range, from ultraviolet to radio frequencies.